Self-ballasted fluorescent bulbs can sometimes exhibit problems like smoking or sparking at the base. Several factors might contribute to these issues. Firstly, a bulb could be inherently faulty due to a manufacturing defect. This can cause it to overheat or spark at the base unexpectedly. Secondly, it's critical to ensure socket compatibility. Different bulb types are designed for specific sockets, and using an incompatible bulb can lead to problems. Thirdly, poor contact can also cause problems. Dirt or debris accumulation on the bulb base or inside the socket can impede proper electrical contact, leading to overheating and smoke. Fourthly, overheating due to inadequate ventilation can cause the bulb base to char or burn. Fifthly, voltage spikes, that is, voltage fluctuations or surges, can overstress the bulb and its base, potentially causing damage. So here are some recommendations to address these problems. Firstly, if you observe any burnt or charred areas on the bulb base, immediately replace the bulb. Secondly, carefully inspect the sockets for any signs of damage or overheating. If you find dirt or debris, clean the sockets. Thirdly, always verify that the bulbs you're using are compatible with the sockets in the ceiling fan or fixture. Fourthly, ensure that the ceiling fan or lighting fixture is well ventilated to prevent heat buildup. And fifthly, if you experience frequent voltage fluctuations or surges, consider using a voltage regulator. Also, if you encounter multiple bulbs exhibiting similar problems or suspect a safety hazard, report it to the bulb manufacturer and the Consumer Product Safety Commission, also known as the CPSC. Here's a more in-depth look at some of these issues. Regarding bulb faults, internal defects within the self-ballasted fluorescent bulb can lead to uneven heating and potential arcing within the bulb's base. This arcing can generate smoke and a burning smell. Manufacturing inconsistencies in the ballast components or the fluorescent tube itself can contribute to these defects. Regarding socket compatibility, using a bulb with an incorrect base type, for example, trying to fit a medium base bulb into a candelabra base socket, can create a loose connection and cause overheating. Similarly, using a bulb with a higher wattage than the socket is rated for can overload the socket and lead to insulation breakdown and smoking. Regarding poor contact, corrosion on the bulb base or inside the socket can increase resistance, generating heat. Dust, insects, or other debris can also act as insulators, impeding electrical flow and causing localized heating. Over time, this heat can degrade the bulb base and socket materials, leading to smoke and eventual failure. Regarding overheating, enclosed fixtures or ceiling fans with limited airflow can trap heat around the bulb, accelerating the degradation of the bulb's components. High ambient temperatures in the room can also contribute to overheating, especially during summer months. Inadequate ventilation prevents heat from dissipating, causing the bulb's internal temperature to rise beyond its design limits. Regarding voltage spikes, sudden increases in voltage can overwhelm the bulb's ballast, causing it to malfunction and potentially overheat. These spikes can also damage the sensitive electronic components within the bulb, leading to premature failure and the risk of fire. Electrical storms or problems with the power grid can cause voltage surges that affect the bulbs. Now let's talk about some proactive measures. Firstly, you should always select high-quality bulbs from reputable manufacturers. These bulbs are more likely to undergo rigorous testing and quality control, reducing the risk of defects. Secondly, you should always check the bulb's specifications to ensure it matches the socket type, wattage rating, and voltage requirements of the fixture. Thirdly, you should regularly clean the bulb base and socket with a dry cloth to remove any dirt or debris. Fourthly, ensure that the fixture has adequate ventilation to prevent heat buildup. If necessary, consider using a different fixture with better airflow. Fifthly, if you experience frequent voltage fluctuations, consider installing a surge protector or voltage regulator to protect your bulbs and other electrical appliances. Sixthly, you should always replace bulbs that show signs of damage, such as cracks, discoloration, or burning smell. Seventhly, you should monitor the bulbs regularly for any unusual behavior, such as flickering, dimming, or excessive heat. Eighthly, you should consider using LED bulbs as an alternative to self-ballasted fluorescent bulbs. LED bulbs are more energy efficient, have a longer lifespan, and generate less heat. Ninthly, if you are unsure about any aspect of bulb installation or maintenance, consult a qualified electrician. Tenthly, keep a record of the bulbs you use, including the brand, model number, and date of installation. This can help you track any recurring problems and identify potential hazards. Self-ballasted fluorescent bulbs combine a fluorescent tube and an electronic ballast in a single unit, offering an energy-efficient lighting solution. However, their design and operation can be complex, and certain factors can lead to problems such as smoking or burning at the base. Let's delve into the technical aspects of these issues, providing a deeper understanding of the potential causes and how to address them. The ballast in a self-ballasted fluorescent bulb is responsible for regulating the current flowing through the fluorescent tube. It also provides the initial high voltage needed to start the arc discharge within the tube. If the ballast malfunctions due to component failure or design flaws, it can deliver excessive current or voltage to the tube, causing overheating and potential damage to the bulb's base. The quality of the electronic components used in the ballast, such as capacitors, resistors, and integrated circuits, plays a crucial role in its performance and reliability. Low-quality components are more prone to failure, leading to ballast malfunction and potential hazards. The fluorescent tube itself consists of a glass envelope filled with a low-pressure gas, typically argon, and a small amount of mercury. The inner surface of the tube is coated with a phosphor material that emits visible light when excited by ultraviolet radiation generated by the mercury arc discharge. If the phosphor coating is damaged or degraded, it can reduce the bulb's light output and increase its operating temperature, potentially contributing to overheating at the base. The base of the bulb provides the electrical connection between the ballast and the socket. It typically consists of a metal shell with one or more contact pins or screws. Corrosion, dirt, or loose connections at the base can increase resistance, generating heat and potentially leading to smoking or burning. The type of material used in the base, such as brass or aluminum, can also affect its resistance to corrosion and heat. The socket is the receptacle that holds the bulb and provides the electrical connection to the power supply. The socket's design and construction can affect its ability to dissipate heat and maintain good electrical contact with the bulb base. A loose or corroded socket can increase resistance, leading to overheating and potential hazards. The socket's material, such as ceramic or plastic, can also affect its resistance to heat and electrical breakdown. Ventilation plays a crucial role in dissipating heat generated by the bulb and ballast. Inadequate ventilation can trap heat around the bulb, raising its operating temperature and accelerating the degradation of its components. Enclosed fixtures or ceiling fans with limited airflow are particularly prone to overheating problems. Voltage fluctuations or surges can stress the ballast and tube, potentially causing damage. These fluctuations can be caused by various factors such as lightning strikes, power grid disturbances, or the switching of heavy electrical loads. Surge protectors can help mitigate the effects of voltage spikes, but they may not completely eliminate the risk of damage. The National Electrical Code, also known as NEC, provides guidelines for the safe installation and operation of electrical equipment, including lighting fixtures and bulbs. Compliance with the NEC can help prevent electrical hazards and ensure the safe operation of self-ballasted fluorescent bulbs. The NEC addresses various aspects of electrical safety such as wiring methods, overcurrent protection, grounding, and equipment listing. Firstly, the Electrical Code Section 410.16 addresses luminaires in closed closets. Secondly, the Electrical Code Section 410.73 covers recessed luminaires. Thirdly, the Electrical Code Section 410.117 addresses ballast protection. Here are some additional troubleshooting steps that can be helpful in diagnosing and resolving problems with self-ballasted fluorescent bulbs. Firstly, you should always start by visually inspecting the bulb, socket, and wiring for any signs of damage, such as cracks, discoloration, or loose connections. Secondly, you should use a multimeter to check the voltage at the socket to ensure that it is within the specified range. Thirdly, you should measure the current flowing through the bulb to verify that it is within the ballast rated capacity. Fourthly, you should use an infrared thermometer to measure the temperature of the bulb, ballast, and socket to identify any areas of excessive heat. Fifthly, you should try replacing the bulb with a new one to see if the problem is resolved. If the new bulb also exhibits the same problem, then the issue is likely with the socket or wiring. Sixthly, you should try using a different type of bulb, such as an LED bulb, to see if it resolves the problem. If the LED bulb works without any issues, then the problem is likely with the self-ballasted fluorescent bulb itself. Seventhly, you should consult a qualified electrician if you are unable to diagnose or resolve the problem. Remember to always disconnect the power supply before working on any electrical equipment. Here's the summary of the key points to remember when dealing with self-ballasted fluorescent bulbs. Firstly, you should always use high-quality bulbs from reputable manufacturers. Secondly, you should always ensure that the bulb is compatible with the socket and fixture. Thirdly, you should always maintain good ventilation around the bulb to prevent overheating. Fourthly, you should always protect the bulb from voltage fluctuations and surges. Fifthly, you should always replace bulbs that show signs of damage or malfunction. Sixthly, you should always consult a qualified electrician if you have any concerns about electrical safety. Self-ballasted fluorescent bulbs offer an energy-efficient lighting solution, but it is important to understand their potential problems and how to address them. By following the recommendations outlined in this narration, you can help ensure the safe and reliable operation of these bulbs and prevent potential hazards. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work or troubleshooting. These professionals have the training, experience, and tools necessary to safely and effectively address electrical problems. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or damage. Always disconnect the power supply before working on any electrical equipment, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, then it is best to leave the work to a qualified electrician. By following these safety guidelines, you can help protect yourself and your property from electrical hazards.